Good morning, my fellow scientists. It's Monday, March 6th, 2017, and I want to talk more about batteries. So, on Friday, a paper came up in my feed talking about a sodium metal battery, and that really excites me because sodium is cheap, sodium metal is high energy, and so what you could have is a high energy density, like lithium ion or better, battery with a really cheap material that you can dig out of the ground almost anywhere or collect from the oceans in the form of salt. So sodium is cheap. Sodium batteries would also be cheap and sustainable if they could be made energy dense the way lithium ion energy is dense. Then we would have something that could store renewable energy for the grid or make solar energy practical for all kinds of places where it really isn't right now. And you could make electric cars more long range, more practical, and cheaper. A sodium battery could be a fraction of the cost of the lithium battery, especially as it gets more widely adopted and the demand goes up. Lithium is going to suffer from supply shortages where sodium just isn't. So really exciting. But why has it not happened before? Well, the problem with sodium batteries is dendrite formation. Let's talk about how a battery works. You're going to start off with sodium ions in some sort of matrix, like maybe a carbon matrix, with maybe a wire going down. The sodium ions are all absorbed to that carbon, and on the far side you have some metal, maybe stainless steel. And in between you have some load or a charger, some power source. Now, when you apply power to recharge the battery, the sodium ions come across and meet up with the electrons that you're driving through with that energy. And what happens is you start to plate sodium metal on this electrode. Once it's all charged, you now have sodium metal that would really like to dissolve and go back across as sodium plus and redeposit itself on that carbon. And at that point, that will force electrons to come around through some load, and that's your discharge. Here's the trouble. When you go to charge it, you're likely to make little sodium metal wires called dendrites. And those dendrites can actually come across and touch your carbon and cause a short circuit, which allows all of the current to discharge through here and the whole thing explodes. So that's bad. To overcome that, you need some separator here. That separator needs to inhibit electrons, right? No electrons, because we want the electrons to come through the wire. It must allow sodium positive charge to pass through. Those sodium ions have to be able to pass through. And it has to suppress dendrites. So this separator chemistry is the big deal. And if you can figure out a separator that does all these things, and is cheap, then you can make a really good battery. So that's exactly what this group has done. Professor Goodenough at the University of Texas has invented a separator membrane that is made out of a sodium glass, suppresses dendrite formation, and is really cheap. And if this all works out and becomes commercial, I see this as a game changer for renewable energy and for vehicle batteries, and really in the transition to cheaper, better, cleaner sources of energy in general. Maybe it won't work out, maybe there are unforeseen hurdles, but this paper is a really encouraging step toward some really cool new technology. Until next time, tune into the Allen Lab and we will talk more about science and batteries and the exciting technologies of the future.